Welcome, everybody. Who's enjoying themselves so far at Next Build 2019? Show of hands. Great. Right, pleased to be here. So welcome back for the third time. So I'm Mike Leach. I'm a solution portfolio manager for Lenovo. And I'm here to talk to you about some AR and VR hardware, and particularly navigating that path and seeing where, when, and how you guys can obviously make use of this wonderful technology. So I appreciate, obviously, Sandeep's pitch there on the NVIDIA RTX Neoscape as well. It's great to see how some of this new technology is really becoming here alive and well and kicking, and everybody can start now and make use of this throughout their coming projects. So, quick, the boring slide really on the bar graph. AR and VR, it's an emerging market. It's changed shape and size. It's been around for a number of years, but it's in a position now where everybody in this room can and should be making use of augmented and virtual reality in their workflows. Everything from training simulations, health and safety training, through to sales and marketing, the use of VR at the very high end. But we're seeing now a huge demand now on AR and particularly VR as well in the enterprise space. So it's something now that is going to continue to evolve as we see the likes of the NVIDIA graphics and Quadra RTX evolving as well. So augmented reality, it's moved on many years from just using your average sort of tablet or smartphone device. It's using that in a very broad number of application use cases. So we're seeing now with a big adoption of AR smart glasses from a number of different vendors, 3D visualization, image overlay from city sort of wider landscapes, health and safety training itself, remote assistance now, using the likes of artificial intelligence to power that remote assistance in the field. The applications and use cases now are very, very broad of how these are being brought to life. And the software tools behind them are now becoming easier to adopt and more attainable by everybody. So we're seeing now a very wide number of growing use cases here. Multi-monitors as well has started to kick off, where you can bring in additional information that can be brought in real time. It can be used from, say, the latest of a data science workstation. Artificial intelligence can now feed in this real-time information that's an image overlay for that construction worker who may be on site. But smart glasses. So there's over 15 separate vendors now out there for augmented reality glasses. The HoloLens from Microsoft is very popular. Magic Leap have brought some new products to market, which they announced at AWE last week in San Francisco. RealWear have now got solutions out there for the enterprise space. But they're all evolving around that same common core of overlaying information to the end user. But it's a hardware device. Who here has had how to play or use the HoloLens? Easy to integrate? Easy to manage? Who's deployed HoloLens? Or is it just sort of one-off projects? So what we found here is a great use of technology, hundreds of different models, 15 separate vendors. But actually utilizing the technology is one thing, but making it attainable and deployable to everybody is completely something else. So Lenovo have brought to market, we announced this last month at our Accelerate conference in Orlando, the Think Reality product. So Lenovo have now come to the market with an AR glass platform. And what this Think Reality platform is, this is codenamed the A6, A for augmented, 6 because it delivers 6 degrees of freedom. And this is a standalone Lenovo headset. We've tethered the compute pack and the headset via a single cable. So we've removed the weight from the headset. Some of the AR glasses out there at the moment that have got the compute power to deliver your experiences are quite heavy, and you can't wear them all day, and they're cumbersomely large, so you can't wear safety equipment and hats and hard hats and glasses over the top. So we've separated the compute power and the glasses into 2 separate units. So the actual the belt clip we have there is the compute pack. That's an Android-powered system on chip with a Qualcomm 845 CPU. And then the A6 has its own separate glasses, and they're tethered by a single USB-C cable. Simultaneous location and mapping, so great features, but it's a smaller, lighter weight, powerful AR device designed for the enterprise. And what we've done, rather than just produce hardware like everybody else, become that 16th vendor in the market, we're actually delivering this with this complete software stack. If it continues. Where are we? Ooh. So not only is it hardware, but we brought a Think Reality cloud software platform to market as well. So it allows you to create your applications. So using the 3D assets you already have, the artificial intelligence data you're acquiring, you can create and deploy your own AR applications. So it becomes a complete sort of turnkey enterprise solution for augmented reality. So we can build into that Lenovo services. That might be support and on-site services. You can build, obviously, then on-device, edge management of that product. So you can deploy a solution out to your users and then update the experience remotely. You can create customer portals, so your own customers can come in and download or modify the platforms you have. You can actually build your own, like an app builder and workflow builder using the assets that you have. And you can integrate it within your enterprise. So if you've bought any of those 15 other manufacturers, HoloLens being one of the examples, you can actually now manage that as an edge device using the Think Reality platform. But moving on to VR. So I'll highlight VR here. So this is actually a screenshot of the Lenovo VR demo we've got up on our exhibition booth upstairs. So what we've done, we've worked with one of our partners, and we've actually created a virtual reality experience here that brings in the use cases for augmented reality, virtual reality, artificial intelligence, using the power of the NVIDIA Quadro and the RTX GPUs with their AI tensor cores. I'd recommend that you have a look at lunchtime and go through the VR experience and see where, when, and how these new technologies are actually being used in real time. So you can experience VR within VR, AR within VR. It's a really good demo. I recommend you walk through it with your colleagues, and you can see then exactly where these use cases can be seen within your workflow. But VR itself, an even broader number of use cases. I won't teach you how to suck eggs, but everything in there, oil and gas, architecture, the use of the photorealism, being able to experience, the famous phrase we have, pixels are cheaper than bricks. If you can visualize something before you've got to build it or make a model of it, you can save huge amounts of time. But it's the content delivery, the content consumption, and the training environments around it where we're seeing a much bigger adoption now of virtual reality. But there's lots of different ways of moving into VR. You can use it on your smartphone. You can have the all-in-one headsets, the Lenovo Mirage, the HTC, the Oculus Quest. Tethered VR headsets, obviously common, sort of most people's sort of de facto of what a VR experience are. But you can also do a lot with 3D caves. But you use hardware in a different way. So everything on the left side, that's a VR experience that you'll pre-create, you'll package onto an Oculus Quest or a Mirage Solo. But it's a standalone device. Limited performance, limited flexibility. Not built for huge, high-resolution graphics, but it's great for creating maybe a health and safety sort of training app or something for maybe a school or a college. Smartphone VR, again, limited use of movement, more like maybe a 360-degree sort of viewer. But on the right-hand side, we're moving now towards more of a tethered VR experience. Are we? We should be. There we are. Yeah, so this is where the workstations come in. This is where you need a lot more graphics horsepower. The NVIDIA Quadro RTX GPUs with their huge frame buffers. These are now where you can dial up the detail, and obviously you can connect multiple users. We're seeing collaboration now more and more within the VR space. But this is where the hardware requirements you need to utilize and really sort of start to ramp up. I think the batteries are flat. Right. So who here uses a VR headset? Who's heard of Oculus? Who's heard of HTC? Right, great. So this is kind of a wide scale of the use cases and the types of VR headsets that are currently out there in the market. So Lenovo, we've partnered with Oculus, and we now manufacture the Rift S, their next generation 2.5K VR headset. And we've actually got that on our booth and running our VR demo, so I recommend you take a look. This is a standalone 6 degrees of freedom headset, really easy to use, just literally USB, DisplayPort, plug and play. But there's other players out there in the market. So the Windows mixed reality headsets are now becoming, more and more, slightly higher resolution, slightly different use cases. Obviously, the money you spend at this point obviously goes up. The HTC Vive Pro is the next one. Should be. So the Vive Pro. Who's used the Vive Pro? Yep, the resolution, the quality tends to get better, the price gets up. Then there's the different players, so Pimax out there now, 5K, even an 8K headset, much bigger, larger resolution, needs an even more powerful workstation to drive this. And when you go beyond there, there's a vendor called Star VR. We've then got VR engineers with their Xtel headset, an even wider field of view. And then we have Vagio, their VR1. Anyone had to play with the Varjo VR1 yet? So Vario are actually upstairs, and they're demonstrating their ultra-high resolution headset. But as we see, there's a range there from sort of sub £500 up to £6,500 just for the VR headset. Now, depending on your use case, whether it's photorealistic detail, is it for basic design review within much earlier stages of the workflow, or you're doing the sales and marketing element at the very, very high end, the use cases are big, wide, but the specifications of workstation that you need to drive this type of experience obviously vary quite considerably. So we're seeing at the lower end, it's more of a mainstream use case at the moment. So 2K resolution, 5 and 8K. Anyone here had to play with a 5 or 8K resolution VR headset? No. I mean, the experience is something else. The wider field of view as well. So you lose the screen door effect. You have a much wider field of view, so you can fully immerse yourself in that environment. You've then got the ultra high quality solutions, and as I say, the Vario VR1, and that's the world's only human eye retina display. So they have a very unique technology, an extremely high quality, high detailed VR experience, and you can read text from the other side of the room within the demonstration experience. So I'd recommend you take a look at the Vario booth upstairs. It's a really impressive use case of how VR can be used, across a much wider field of use. The Rift S, the Oculus, the low-end headset, that's great. Everyone can have one of those plugged into their workstation and keep it in the desk drawer. They can immerse themselves in and out of a VR experience every few minutes as part of that low-end, that sort of design element. But obviously then when you start moving further up to create the experience, the sales, the marketing side of things, that's obviously where the design review use cases with the likes of an Xtel or a Vario VR1 really, really come into their own. But virtual reality isn't just a VR headset. So 3D caves, VR within a cave environment, a 3, 4 or 5-sided cave. It's been around for the last sort of 10 or 15 years, but it's now in a position where you're driving 16K resolution caves. That's an installation we have in North America that's powered by 10 of our ThinkStation P920 workstations, and it's driving 120 individual monitors. So less of a virtual reality, but an immersive experience to a full 360-degree view. So once you create the content, there are now numerous ways of delivering a viewable experience for that, and a great way to collaborate, on the high-end projects with, with a large number of people design and review. So why workstation? So I'll keep it brief, but essentially you need ultimate performance. All VR experiences are driven by the CPU clock speed, the faster the better, and the GPU clock speed and the GPU memory. So a workstation from us, our VR platforms are around the 4.5 gigahertz clock speed. They're extremely reliable. Obviously, you don't want something to fail, so these things are being run 24/7. Low acoustics. You don't want to stand next to a jet engine whilst you have your VR headset on, so it wants to be cool, quiet, reliable. We're using the NVIDIA Quadro RTX GPUs, and we can support 2 of these for up to 96 gigabytes of GPU memory. So for the world's most powerful, highest resolution, the highest fidelity VR experiences, workstations are key. With the ThinkStation platform, we've got enterprise security, we've got our own Lenovo performance tuning software that can speed up the VR experience, and then every platform we have is NVIDIA VR ready. So what I've done, I've put together sort of like a recipe card sheet, but essentially, the reason you need a GPU, or as you move into a VR headset, the screen on the left needs a screen output 60 megapixels a second, and that's just driving your average 27-inch full HD display. You move to a fairly low-end but fairly standard Vive Pro headset, and the GPU is working nearly 8 times as hard. So you move up to something like a Vario VR1, or you increase the resolution of the headset, the GPU's got to work significantly faster. When you add in the real-time effects and the RTX GPU capabilities, you need to move up the stack. So whereas you might have been a mid or a high-end GPU customer with normal display, when you start working more and more with a VR environment, it's very important to make sure you choose the right GPU. So the Quadro RTX 4000, 5000, 6000 or 8000 are on that stack as a VR-ready platform built to give you that 7.5 to 8 times more performance, to give you the best experience. There's typically a good or a bad VR experience. No one wants a bad one. And that magic cycle, cycle there, motion to photon. So you move your headset, you then have to relocate. It goes into the CPU, into the GPU, and back out of the GPU to your headset. So when you move your head around, you don't get latency, you don't get lag, and that's where you need to have the full cycle of less than 20 milliseconds. If you have anything more than 20 milliseconds, that's where you drop frames, the latency, and you start feeling a little bit queasy and not a great VR experience. So having the right GPU, the right workstation, and configuration under the hood is what gives you then that completely immersive experience that's just seamless from start to finish. And these are some configurations that we've put together. Particular ones to highlight here are the ThinkStation P520 and P330 on the desktop side. These give the fastest clock speed, the most flexibility on a GPU, and they're designed for, say, VR content creation and VR content consumption. But everything end-to-end within the portfolio for us is available VR ready, and we're happy to talk to you about certain configurations, be it desktop or mobile. But a worldwide announcement. So I'm pleased to be on stage a few hours late, but essentially we did announce at 9 o'clock this morning the largest ThinkPad mobile workstation announcement in the history of Lenovo. So we've put together now a complete refresh of this portfolio, available to see on the booth upstairs. We've launched the ThinkPad, the P43S, which is the industry's lightest mobile workstation. We have the 53S, a 15.6-inch Ultrabook, the industry's lightest, nearly 15 hours of battery life. We have the Gen 2 ThinkPad P1, which is now our most powerful, full-fat Ultrabook. We have the industry's thinnest 17-inch mobile workstation. And to top it all off, we have the new ThinkPad P53. Come on up. There we go. So as Sandeep mentioned, this is the most powerful 15.6-inch mobile workstation on the planet. Intel Xeon CPUs, 8-core, 128 gig of memory, the NVIDIA Quadro RTX 5000, 16 gigabyte, the most powerful Quadro RTX GPU available in any laptop today, to 6 terabytes of storage. It's a 100% color accurate OLED display. It's a beautiful platform. What used to be in the larger 17-inch products, we've now delivered that to you guys in a 15-inch product. So for real-time rendering, virtual reality, you can now do this in a much more mobile 15.6-inch platform, and the P53 is that platform of choice. Any questions?
How much is it?
Cheap at twice the price. So I'd have to defer to my UK sales colleagues in the room. This was announced this morning. We've got ship support later next month. And so speak to us on the booth and we can give you some example pricing options.
Other questions? Mike will be upstairs too during lunch and during breaks.
I've also got the Think Reality platform for show and tell if people want to have a look at that as well.